Today I'm going to talk to you about polynomials. Now you may have already come across polynomials of degree 2 before. So a polynomial of degree 2 is where the leading term has an x squared. So here's an example of a polynomial of degree 2. So this is a quadratic and this is what we call the leading term because it's the highest power. A polynomial of degree 3 is a cubic. So an example of a cubic is x cubed. Now let's do the general form, ax cubed plus bx squared plus cx plus d. That's general form of a cubic or polynomial of degree 3. A quartic is a polynomial of degree 4 where the leading term is the highest power, so that's x to the power 4 plus bx cubed plus cx squared plus dx plus e. Obviously for each of these, a cannot equal 0, otherwise you wouldn't have that leading term. Alright, and similarly for this one. Now what I'm going to show you to do today is how do we divide a polynomial. We'll probably concentrate on cubics, but how do we divide a polynomial by another linear factor? I'm only going to consider things that divide exactly, so i.e. we're left with no remainder. In maths methods, we don't consider anything other than a remainder of 0. However, it is still possible to divide other linear factors by polynomials and not get 0 as the remainder. We won't look at that. Okay, so I'm going to show you how to divide this cubic by this factor x plus 2. Now, what would be the reason for us doing this? It could be because we want to sketch the cubic graph and we need to find, well, where does this cubic graph cut the x-intercept? If it cuts the x-intercept, it might only cut it once, twice, or 3 times if it's a cubic. There are various scenarios for a cubic graph. What we can do is by dividing by one factor, we can say, assuming we get the remainder 0, that minus 2 is a solution. So minus 2 would be where it would cut, or one of the places where it would cut the x-axis. So I'm going to show you how to do this division. Now the first step is to set up the old style bus stop method. So I'm going to divide, that's going to be what I'm going to divide by, and within the bus stop I'm going to have my polynomial x cubed plus x squared minus 14x minus 24. So the first thing we say is, well, let's just take the x term here of our linear factor. Let's try and work out, let's divide x cubed by x. So dividing x cubed by x gives us a whole x squared. The next stage is to then see, well, what's left when we multiply our divider by these two things, by this x squared here. So x squared multiplied by x gives us x cubed, and then 2 multiplied by the x squared gives us the 2x squared. Let's find out what's left. So we subtract x cubed, take away x cubed is 0, so that's disappeared. X squared minus 2x squared leaves us with minus x squared. And then minus 14x take away the 0 is minus 14x, and minus 24 take away the 0 is minus 24. Then we do the whole process again, and we divide this term by the x. So we're continually dividing by the x every time. So let's divide this by x. Well, minus x squared divided by x gives us minus x. And then we do the multiplication. We say, well, okay, let's multiply our x plus 2 by our minus x. X multiplied by minus x gives us the minus x squared, and 2 multiplied by the minus x gives me minus 2x. And we do the subtraction again. This disappears. Minus 14x minus minus, that's plus, minus 2x is minus 12x, and then I'm left with minus 24. And we repeat the process again. We divide x by this remainder here. Well, minus 12x divided by x leaves me with minus 12. And I've got the multiplication process to do. Well, let's times this by the minus 12 and see what remainder we have. Minus 12 times x is minus 12x, and positive 2 times 12 is minus 24. Then you do the subtraction again. And what you notice is that minus 12 minus minus plus 12 gives us 0. Minus 24 minus minus 24 is 0. So we are left with the remainder of 0. We can now say that x cubed plus x squared minus 14x minus 24 divided by the x plus 2 gives us this quadratic expression, x squared minus x minus 12, with no remainder.